All right. Well, I want to begin with some good news. For the first time ever, North Carolina has a sustainable statewide addressing solution. The reason for that is because of the Next Gen 911 program. And so really think about the keywords there are reliability and confidence. We have confidence that the data will be there for a while. So what I want to do today is walk you through what CGIA does. CGIA is the organization that I'm with. We're the project manager for the program. And I wanted to just step you through what CGIA does with the data, how we quality check it, and how we get the information back to you, and what we can help you with to improve the data the next time it goes through Next Gen 911. So as the data moves from the county providers and the local government providers through Next Gen 911, it passes to AddressNC. And so it's a one-way street from provider through Next Gen through AddressNC, but it's really a full circle approach so that what we find we can put back to you, and maybe you can find the things that we found as well. So I want to begin with our areas of focus here. So we look at 7 big categories of workflows as we take the data from Next Gen. And so the first 2 are really about the tabular side of the data, the consistency standardization. We have 100 plus inputs going through our funnel. And so what we want on the outside coming out of it is a standard, a consistent standard. So we'll talk a lot about that, and I'll show you what we do to achieve that. It's also about ease of use for the end user. If you're working in desktop GIS, we'll show you how that's going to help you. We also look at the spatial side of what we can do with the data. So we take it, overlay it with the official statewide boundary data sets, counties, municipal boundaries, zip codes, and check it against that. Quality control, we do so much with quality control, but obviously we put the focus on the address and the sub-addresses. There is an abundance, tens of thousands, hundreds of thousands of sub-addresses in the data. There's about 6 million points statewide. But we also look at other things like the boundary, the municipal boundaries, the political data coming through, and other information that we correct and code. So I will say AddressNC being a GIS program, it is a total coded data set. So that allows us to change things on the fly. It allows us to automate the reporting back to you, and we can communicate those coded domains so that you can understand what we're giving you. And then finally, we provide spatial means of what we find the quality control results, so you can look at that and understand what it is that we found. And it's all done through spatial output, and there's no PDFs or tabular data that we deliver. So I'll begin with the consistency side of it. I won't go through all of this, but there's 7 different ways to spell avenue, and there's 16 different ways to spell unincorporated. And so with AddressNC, you'll find one way. And we put a big emphasis on standardizing all that information. We look for invalid data that's irrelevant. We don't care if the building's red, we care that it's building 1. So we take out prefixes, we take out typos, abbreviations, all that. Everything is standardized, everything's uppercase, and everything's either a null format. There's no blanks, there's no trailing spaces. So it's all good for the end user when you're dealing with that. Here's some examples on the right here of different spellings, what the raw data might look like. And so you'll never see that with AddressNC. So standardization and consistency are closely related, but they're a little different. So in terms of the addressing part of the data, we adhere to the NENA standard, 911 NENA standard, for those subparts of the address. And so the street type, the street separators, the modifiers, the directional, all that data is standardized. And so you can see here a couple of examples of what the raw data looks like. We have lookup tables that convert it from the input to the output. So for example, 121 is not a valid value for a direction. And so we will we will change that, we'll code it, and then we'll give that back to you and you can see what we found. So I wanted to talk about the ways that we deliver the data to you. So this is an example of what we call our input-output. So from that standardization and consistency that we just did, this is our way to deliver this back to you through a spatial hosted feature class on NC OneMap. So we give you 10 layers of what we found, and those are zip codes, boundaries, addresses, things like that. And so our mission here, this is the keyword incentive for the end user, is we don't want you looking through 75 fields of data, because horizontally scrolling through and trying to find what you're looking for. So we give you just the amount of information you need to see what we did and what we recommended to make that change. So once again, incentive is a big deal with that. So we also provide a means to show you what the data looks like now and what it looked like when it was raw coming through Next Gen 911. So in this example right here, the blue is what the data is currently, and over here on the right are the original values. So you can see here these highlighted green, well, light green, whatever color that is. So for example, in the first one, there was 2 fields that were populated with the same value, in the adnum suffix field and the unit field. So if you put those strings together to build an address string, we don't want redundant data popping up, so we take out one of them. You can see here for prefixes, the intent of the field is to show the value of the apartment. We already know it's an apartment, so we don't need that keyword there. So expect to see that. And once again, there's your coded domain, there's your intuitive descriptions of what we're giving you. And this is just an example of the attribute table that you'll see when you pop open the GIS layer. So we also do spatial overlay conflicts to see what you gave us versus what we found when we did a spatial overlay. And we do that for the state official boundaries, the county, the municipal boundary data set, the official statewide set, and the USA zip codes. So in this example right here for the town of Newport, all the selected set in blue were coded as Newport, but they don't fall inside the municipal boundary. So we code that. It's not wrong, it's not right. We're just reporting that this is what we found. The same with counties. I believe this one, the value was HC for Harnett County, but programmatically we can't know that that's Harnett County. So regarding those conflict layers, we'll turn back 4 layers to you through NC OneMap to show you what we found. And this is an example of the municipal towns overlay. So in this example, we say that the incorporated municipality is different than the overlay. So you said Chapel Hill, we say Durham, according to what we found in the spatial overlay. And in the second row here, our data tells us that Carolina Shores was incorporated in 1998, but yet Calabash is in the unincorporated field. So we can't have both. It's either incorporated or it's not. So we report that to you. So then getting past the tabular side of it, moving it more into the completeness side, the completeness is as important, I feel. So we have at least 4 different ways that we analyze the data to see if things might be missing or if they're incomplete or if something is maybe coming online that we want to show you. So in this example right here, this is using the statewide parcel data, which is very reliable. We can look for the improved values on parcels and query that in GIS and determine that there's no red dots here. And so clearly this is a developed structure with houses, but there's no address point. So we report that back to you. You'll get a layer called the conflicts or completeness layer. Pop that open and you can go right to it and see something's missing. So in the keynote yesterday, we talked about precision. And so here's an example of finding points that are in a street. We feel those points should go on the building, the structure that they're located on. Here's an example of platted development that's coming online. FYI, you might want to look here the next time you go back to look at your data. And then finally, redundancy. So here's an example of a perfect situation where we have sub-address units for all these apartments. But a lot of times we just get the parent address. So we might have 500 points that have the same address. And so sub-addresses and units are very important, especially for 911. Okay, so has anyone heard of NC1 map in the crowd here? All right. So to learn more about the program and details and specifications and everything that you could imagine, go to the AddressNC project page on NC1 map. You can learn about the schemas, you can read up on it, you can understand those coded domains. We have a geocoding app there, frequently asked questions. So go to this page and everything you need to know is there. So if you're using the data in an offline environment without internet, disconnected, we can go to NC1 map and go to direct data downloads. You can search for your county. You can search for the entire state and download it local for desktop GIS. And also we have a geocoding locator file that you can download for offline use as well. You don't need the data. We have a geocoding service that you can package on your own hard drive. But it's important to know that when we do updates, you'll have to replace that and re-download it if you're not using the streaming service. So getting to the data, how do you get it in your desktop GIS environment? So we highly recommend plugging in the CGIA REST endpoint services to your catalog, session, and pro or map. And once you do that, you can see here on the right, AddressNC is almost at the top of the list here. There's our geocoder, there's the points, the address points, and there's all those inconsistency layers that I've talked about. Drag those into Pro, filter on your county, and you're ready to go. That's how you can review what we found. So then the geocoding service, I know a lot of people are interested in geocoding. It's very popular. At the keynote yesterday, William Johnson spoke about, like 30 different geocoding unified services. And so for North Carolina, we have one, that's AddressNC. So a geocoding service is an open API. You can use it outside of the Esri environment. You know, we provide a web app interface to let you to look at that, desktop GIS. And the good news is there's no credits required to use our geocoding service. So keep that in mind. Next, I want to show you all the things that geocoding can do. So most people think of tabular geocoding. They have an Excel file and they want to create an address for it. But there's many other things you can do. Once again, no data is needed for doing geocoding. You can scan it with your phone if you want to. It operates on your phone, if you have a good phone, I should say. And there's the short address for the web map service. And so then I wanted to end with the geocoding and give you some examples of what you can do. Once again, take the REST endpoint that we give you, add that to your pro session, add that to your project, go in here, click on AddressNC, and you can begin to do locating as well. Reverse geocoding, if you have thousands of polygons that you want an address on, you can do reverse geocoding. I can think of 5 million building footprints across the state that need addresses on them. A lot of people don't know this. You can right-click in Pro and say, what's here? It'll find the nearest AddressNC point and tell you what's nearby. And then, of course, you have tabular geocoding, which is the most common use of geocoding services. Pop open that Excel file and geocode it. So then I wanted to end with our web app. This is we host a web app on NC1 map. And you can also do geocoding in the pro session as well. And I want to really just end with a focus on these sub-addresses. We put a lot of emphasis on those to clean them up, standardize them. And so here's an example where in our locate, we have type ahead functionality, which is really nice. It's really fast. So here we typed 1579 Painttown Road. Well, that's great. It gives us the parent address that it found. But if you hit space and hit a number or a keyword like apartment or unit or suite or whatever keyword you can think of, you're going to begin to see all the things that really exist at that parent address. So in this example, there's a list of 15 subunits that are there. That's a great indicator that you might have a multifamily complex in the area. Maybe there's duplexes, apartment building. So that really opens up your eyes to what's really there. And then, of course, up here on the upper right is what you will find by doing that. And the great thing about the data is it's not just sitting in the middle of the parcel, it's distributed across the locations where they really are. So check out the web app if you get a chance, and let me know if you can break it. And that's about it. So give me a call. I'll talk about this all day long. I want to, CGIA can assist you with anything that you need, whether it's placing the data more on structures or moving it, or helping you automate your workflows or evaluate what we found. We are staffed to support you. And so give me a call if you need that.
All right, does anybody have any questions for Darren? Yeah, Darren, can you remind us, you started working to reconcile with what's the zip code file?
So the zip codes, the zip codes are the thing I hear the most. So if you remember, we're taking the data as is from the authoritative provider, and like I said, we're standardizing it and do all those things. So the best that we can do is take the zip code data that we find and run that up against the national zip code polygon boundary data set. So we don't change any values. We don't change your data. We might standardize it, but we report on it. So if we find a conflict, we're just reporting that back to you. And that's what we do with zip codes. But we do lots of things where we might have an entire zip code string, and we break that apart and put it in the proper fields that it goes into. So that's what, if you go to our conflicts layer through NC1 map, you'll see a layer called zip conflicts.
I'm talking about run all of the address points through address validation and batch, then contacting the AIS office and Greenfield and Charlotte to reconcile all the work we've done, so it's teams of four. And we did that in 2014 data. The NC machine, somebody else did it before you did it, which is about to get some counts. You're one of the things we didn't have to do. For your answer, I guess, we probably keep on doing this, which is fine. We're glad to do it. But it takes some work for that. If this gets reconciled with a zip-4 product, then there can be at least partial geocoding for us, patients at hospitals. And they have a much more accurate association with address and value.
I do know that I'm starting to see in the data coming through NextGen, I am seeing the +4 field now. I never saw that before, and that's something that we're looking at as well. That's new. So, but we can talk about it if you want to meet next week.
My question was also about the national zip code layer. Can you tell me a little bit more about that?
So that's the best data source that we use to do these overlays. It's the authoritative national zip code boundary data set. Or I get that set from the FGDC hosted layer. But I've seen that it's also authoritative. If you look at, when you're looking at the ArcGIS Online details for a layer, it says it's the authoritative set. So that's the best one that we use. However, I understand there are alternative sources that might be better. I don't know. That's the one we use to do the reporting, though.
So, I mean, if I make it as an county zip code layer every week, then I don't know how the national system might get that information.
I don't know. I do know. I've heard many times that a mailing zip is much different than a CITUS zip, and that's a big consideration because ours is all CITUS. So keep that in mind too. But we need the zip code. It's essential to doing the proper geocoding. So it's the most important part. one of the most important parts of the address.
More questions? How about street change is meaning? Street name change, can you update your address?
So once again, we're taking the data as is. So if the provider changes the street name every month, and that's a good point. Our plan is to update every month. So we get the next gen data out, process it, and replace the old with the new. So whatever's there is there. That's another good point too about street names is there's no such thing as a zero street number. And so we look at those as well.
As we look to the future, should we be maintaining historical data to understand what's changed over time in the address fields? Perhaps that would be useful down the road. Is that something that we should look collaboratively across state legislature?
So as part of the monthly processing that I do create a version 1, version 2, and maintain those. And that's going to, so we have that on our end. I can't speak for the counties and the providers or what they're doing on their end. But what that's going to help us do is what I call phase 2 of the program now is to start doing all the online dashboarding and experience builder and doing analytics on the information. And so one of the things that comparing the V1 to the current is going to let us do is see growth. Because it's important from the public front end to see growth and to see progress that the program's building. And so that's one way that we're going to do that is by using those historical records. Mm-hmm.
Any last questions? All right, thank you, Darren.
Thanks.